ever experienced pain after a honey bite? What first aid will you give to reduce the irritation? You may apply baking soda paste to it, right? Why did you choose soda paste? In fact, bee injects methanoic acid into the skin through their stings, and that is why you are experiencing pain. And this acid is neutralized while applying baking soda. Here, methanoic acid is neutralized by basic soda. Now my question is, how will you identify a compound's acidic, basic or neutral nature? In this video, I would like to introduce you to a scale called pH scale. It helps you to differentiate between acidic, basic and neutral substances. The pH scale was introduced by S.P.L. Sorensen. The scale differentiates acidic, basic and neutral solutions based on the concentration of hydrogen ions. The pH of a solution is defined as a negative logarithm to the base 10 of the activity or molar concentration of hydrogen ion concentration in that solution. Thus, a solution of HCl with 10 raised to minus 2 molar concentration will have a pH of 2. Now, can you calculate the pH of water at 298 Kelvin? Well, at 298 Kelvin, pure water has a hydrogen ion concentration of 10 raised to minus 7 molar. Hence, the pH of pure water is 7. That is, in neutral solutions where there is an equal number of hydrogen ions and OH minus ions, the pH would be 7. On the other hand, in the case of acidic solutions, the concentration of hydrogen ions would be greater than that of OH minus ions. Or you can say that the concentration of H plus ions will be greater than 10 raised to minus 7 molar. Then the pH would be less than 7. For basic solutions, the concentration of H plus ions will be less than that of OH minus ions. That is, here the concentration of hydrogen ions will be less than 10 raised to minus 7 molar. Hence, the pH is greater than 7. Next, you may recall the ionic product of water, the Kw. Ionic product of water is the product of concentration of H plus ions and OH minus ions, and its value is 10 raised to minus 14 molar. Taking negative logarithm on both sides of equation, we get negative log Kw equals negative log concentration of H plus ions minus log concentration of OH minus ions, which is equal to negative log 10 raised to minus 14. Thus, you may represent the ionic product of water at 298 Kelvin as pKw, which is equal to pH plus pOH, and its value is 14. Based on this pKw value, the pH scale has markings ranging from 1 to 14, and the nature of the solution, acidic, basic or neutral, is decided based on these values. Now let us see how to measure the pH of a substance. The pH of a solution can be found roughly with the help of a pH paper. The pH paper shows different colors in solutions of different pH. This provides an accuracy of approximately 0.5. Hence, for greater accuracy, you may use pH meters. This device measures the pH-dependent electrical potential of the test solution with a precision of 0.001. Nowadays, pH meters of the size of a writing pen are available in the market. Now, can you tell me the importance of measurement of pH? Well, the measurement of pH of a solution has manifold applications. I can give you a few examples. In the production of cosmetics, formulations with a pH of about 4.7 are maintained, and it is beneficial for the skin. Similarly, the pH of water is very important while concerning its quality. Water that is too far outside a scale of 6.5 to 8.5 are not safe to drink. Besides, pH affects vegetation. At extreme pH, the availability of some of the nutrients is decreased. Hence, proper pH is important to crops too. Thus, pH has various implications in our day-to-day life. However, the use of pH to indicate the strength of acid or base is limited. This is because pH changes with change in concentration. Therefore, the dissociation constant was found to be a better alternative to express concentration in the case of weak acids and weak bases. We learned about the concept of dissociation constant in our next video. Now, let's summarize what we have learned.
Manorama Horizon. Learning made simple.